The rates for two homework help services are shown below. Homework SOS is given to us in graph form, and Homework Lifeline is given to us in word form, in which the amount that it costs to sign up with the company, or the initial fee, is $25. Then we pay 40 cents for each minute of homework assistance. So because this is the amount that will be changing, it is our slope, or our rate of change. So for this problem, we have to answer which service has a greater rate of change. Well, we know for Homework Lifeline, our slope is 0.40, or 40 cents for each minute. On our graph, we can either use the rise over the run, or we can pick 2 points to determine the change in y over the change in x. So our first point on the graph is 0 and 10, and the next point is 10 and 15. So as you can see, from 10 to 15, our slope increases by 5, and from 0 to 10, it increases by 10. If we were to write this in decimal form, just like Homework Lifeline, we would get 0.50, or 50 cents per minute of homework assistance. So in this case, we can answer the question in a complete sentence by stating that Homework SOS has the greater rate of change of 50 cents per minute of homework assistance. So our slope for the first equation was 50 cents per minute, and we have a y-intercept, or starting value, of $10, which means that for the first company, our equation is y equals 0.5, or 0.50, times x plus a $10 registration fee. For Homework Lifeline, we have y equals 40 cents per minute of homework assistance plus a $25 registration fee, or account service fee. So because we're asked which company charges less for 120 minutes, we now need to determine, are we plugging in 120 for x or for y? Well, on our graph, we can see that our x-axis represents the number of minutes, while the y-axis represents the cost. So x represents the time in minutes. So we're going to do the substitution and work it out for both of these examples. So after having substituted 120 minutes for each equation to figure out which homework company charges less and by how much, we can see that the first company, Homework SOS, charges $70, which is $3 less than Homework Lifeline. What we're going to be looking at today is the start of our third unit on transformations, or more specifically, geometric transformations. So when we think of the word transformation, we know this has to do with some type of change in either shape or size, or if we're thinking of real life examples, something like metamorphosis, for example, a caterpillar transforming into a butterfly. So there are 4 geometric transformations that we're going to be studying. A translation, which is a slide either left or right, or up and down on our coordinate plane. A rotation, which is a turn about a point, that's that little dot right there. We have a dilation, which is a change in size. So another time you might have heard that word dilation is if you've ever gone to get your eyes checked out by the doctor and they dilate your pupils, which is that small black spot on your eye that gets larger and smaller, or it enlarges and reduces in size. And we have a reflection. So a reflection is when an image is reflected over a line. So in this example, we're taking this blue trapezoid and flipping it over this vertical line. We can also do a horizontal reflection. So you can think of a reflection as a mirror image. Please take a moment to write down the transformation definition and the meaning of image and pre-image on your class notes section of your handout. So a transformation is a general term for 4 specific ways to manipulate or change the shape of a point, a line, or a shape. The original shape of the object is called the pre-image. You can think of this as the before. And the final shape and position of the object is the image, or we can call it the new image under the transformation. So this would be the after. So again, the 4 types of transformations are a translation, and go on ahead and fill in these hint words or clue words next to each type of transformation. So a translation is a slide. It's when we slide the image up and down, left and right. A rotation is a turn. Think of the wheels on a car turning or rotating. A reflection is a mirror image, or a flip over a vertical or horizontal line. So translation is a slide, rotation is a turn, reflection is a mirror image or a flip over a line, and a dilation is when we enlarge or reduce an image's size. Let's take a look at the bottom 2 examples on your handout. So for number 1, this is an example of a translation. So we've taken this pre-image of this flag and we have translated it or slide it to the right and slightly lower than its original image. One very important thing to identify here are the points on this flag. So in our original image, we have a triangle made up of A, B, C, and this pole of the flag is created by the segment AD. On our new image, to say that this is the after, we have these apostrophes next to each of the corresponding letters from the pre-image. This is called a prime. So from A, we have translated to A prime. From B, we have translated to B prime. From C to C prime, and D to D prime. Notice that all segments and angle measures from the pre-image to the new image have remained the same. Nothing about the shape or the size has changed. The only thing that's changed is the location of the image. Example number 2 is a rotation. And a rotation is when we turn an image, either clockwise or counterclockwise, going the other way. CCW is how we'll notate it. So this image has turned 90 degrees clockwise. We'll talk more about specifics on the degree rotation in a following lesson, where we have a 90-degree rotation, 180-degree rotation, or 270-degree rotation. So for now, all we need to know is that a rotation turns an image, and once again, we are notating the location of the new points using our primes, A to A prime, B to B prime, C to C prime, and D to D prime. You don't need to draw all these arrows on your handout. I'm just showing you that each point on your pre-image or your original image has to match to the new location of your new image. Okay, and in example number 3, we have our first example of a reflection or a flip over a line. So if we were to draw the line of symmetry, or the line in which this flag ABCD was flipped or reflected over, it would be a vertical line going evenly between these 2 images. So now every point is an equal distance away from this line of symmetry. So A is an equal distance from the line as A prime would be. B is an equal distance as B prime, and so on. C to C prime and D to D prime. So a reflection is a flip. And just like in the first two examples, all the segments and all the angle measures have remained the same. Nothing has changed except the location of the image. One of the last transformations that we'll be studying is a dilation, where an image is either reduced, like in this example, or enlarged, as in the second example. So it's not included on your handout. The only three that we're focusing on today are reflections, translations, and rotations. So you have the remainder of the period to work on Station 1, which is our new topic, and there's also a spiral review station on scientific notation, because we need to continue going back to study topics that we have already covered to make sure that we continue to review them.